Okay, today we're going to work on scatterplots and association. There's some vocabulary that we need to learn, and then you'll realize that even though we're plotting scatterplots that don't line up perfectly like a straight line, there is a way to use algebra and equations of lines to do predictions with scatterplots, and we'll call those trend lines later in the week when we get to that lesson. Right now we're going to just focus on what a scatterplot is and what the associations are that you need to be able to identify. So on your note sheet, what you're going to do is you're going to start by filling out your vocabulary here in the middle. Scatterplots are graphs that use points to display numerical data that have two variables, and it's often called bivariate data. Bivariate meaning because there's two variables. Scatterplots can help determine if one variable has an effect on the other, or if there are overall trends, patterns, or association between the variables. So again, there's some words up here that we need to make sure we have down, and then we'll come back and revisit these words so we learn what they mean. Susie went to the mall and surveyed shoppers to see how many items they purchased and the total amount of money they spent at the mall. What you want to do whenever you're given a graph like this is you want to look very closely at the labels. These are representing the numbers of items. These are representing the total money spent on those items. So what you will have to do to find out how many shoppers Susie surveyed is you will actually have to count the dots. Each count represents one of the shoppers that they surveyed. This shopper right here bought 2 items and she only spent $20. This shopper spent bought one item and spent $40. This shopper up here spent $140 and bought 3 items. So by counting all the dots, you should see that there are 16 of them, and that's how many people were surveyed. Overall, it seems that as you increase the number of items, the price went up. And this is typical because, again, if you buy more items, you're typically going to spend more money. This is an example of a positive association. A positive association is when the two variables move together. So they either both increase or they both decrease. So in this example, one variable increased, the numbers of items bought, and then the other variable, the total money spent, also increased. A negative association is when two variables move in opposite directions. For example, as this variable increases or gets larger, the points end up falling and you have this negative. Remember slope dude, nice negative? You have a negative association if one decreases and the other increases. Slope dude, if we had a line to graph on top of this, which we will later in the week with a trend line, he'd say puff puff positive to show a positive association. And then the other idea is that there is no association when the points do not line up in any way, shape, or form. If they're just scattered all over the page and there doesn't seem to be any pattern, we say there is no association. A couple examples to look at. The hours a person studies and the number of states they visited will have no association. The hours a person studies and the grade on their exam is typically a positive association because they're spending more time studying the content and they want to do well on the exam. The third one says the hours a person studies and the hours they spend watching TV has a negative association. And we say this because if you're watching TV, you're not studying as much. So you would have a negative association. This would have to go down to leave you more time to spend watching TV, or if you're studying a ton, you won't have the time to watch TV. So the variables go in opposite directions for this last one. On the back of your sheet, we're going to take a look at how a straight line can be drawn, and this is going to follow the overall trend of the scatterplot. It's called linear, and we learned that in our last unit. If the points line up, we have a linear relationship. If they don't line up, it is nonlinear. In a scatterplot, if the points are close together, we have a strong association, but if the points are widely spread out, there might be a weak association, or if they're spread out a long ways, there would be no association. Down below, you've got some examples to play around with to see if you can get comfortable with whether it's linear, nonlinear, whether it's a strong relationship or a weak relationship. So try these, pause the video, and then play it so you can check your answers. For the first one, you have a positive, strong, linear relationship because the points line up. These points are still positive and linear, but we consider it weak because the points are not that close together like they were in the first one. These points are strongly put together in a group, but it is nonlinear because you see the curve. It's still positive because it's going uphill. The last three are actually number 4 and 5 are both negative because the points are heading downhill, like slope tube would say nice negative. This is a strong correlation because the points are very tightly packed together, where these are weak because the points are a little bit apart. This would be considered linear, and this has more of a curve to it, so we would say nonlinear. The last example has points scattered all over the place, so we would say there is no association, and it is non-linear as well, because again, the points do not line up. Now, the next table has some examples of what two variables could be. Typically, if you think about a child when they're growing and they get taller and taller, their feet are going to grow also. So if we compare this to a child's height, as the child grows and increases in height, the child's foot is also going to. So a positive relationship is the height of people increases, their shoe size increases. For the next one, the number of letters in a person's name is the first variable, and the second variable is that person's IQ. This is going to have no association. It doesn't matter how long your name is using the number of letters. It's not going to dictate what your IQ has or what your IQ score is. The last one has us comparing the number of absences a student has to the student's GPA, and typically this would be a negative association. The more you're absent, the more school you're going to miss, and it's going to be more difficult for the student to make up. So typically their GPA or their grade point average will be lower than if they had less absences. So those things are going in the opposite direction, so we would have a negative relationship. On the bottom, it's a little confusing, but they have 3 scatter plots and they have 3 descriptions. So what they want us to do is they want us to see which one describes the picture that we see. A is actually going to be described by this picture. The temperature outside and the total gallons of gas sold really doesn't have any association with each other. The gas, people need gas when their tank is empty, so it doesn't matter what the temperature is, they're just going to fuel up when they need it. B is the description right under the graph here, the size of a home and the cost of the monthly utilities. A lot of people that have a really small home, they're not going to pay very much because they don't have that much space to heat. The really big homes, as you increase out, it's going to cost more because you have more space. And the first graph actually matches the example down here, the altitude of a hiker. The higher you get up into the mountains, there's actually less oxygen in the air for the hiker to breathe. So as we look at the relationship, the altitude increases here, the oxygen level is lower. So that's the negative relationship that we talked about. Now what I need you to do is I need you to take a look at the assignment. This is the handout that says Homework 1 on the front. And what you're going to do is you're going to go through and you're going to look and see what you can answer as far as these association questions about scatter plots. When you're finished, you can play the rest of this video. Okay, checking your answers to your assignment. What we have here, we have the relationship here about people driving to work and the last digit of the phone number. That leaves us with no association. And the reasoning is it really isn't going to rely on the digit that you were assigned as a phone number based on the distance you are from work. There's no association. This one does have a positive association because typically the longer a student stays in education, the higher level of income they are going to have. Down here we have a negative relationship, we have no relationship, a negative, and positive. Even though it's a weak relationship, the points are not close together. It is heading uphill, so it has a positive relationship. Number 6 could explain a person's age and height as long as you're thinking about a child who is growing up and getting taller every year. Number 8, scatterplot can be used to show the relationship between a person's age and the number of syllables in the person's first and last name. Again, no relationship between your age and the letters in your name, or in this case, syllables. On the back, you should choose option C. The points are headed uphill, so that's a positive relationship. It's also linear because they line up, which would not likely represent the situation. Choice B, because the number of students in school, as it increases, it's not going to give you more unused lockers. It should give you less unused lockers. So that can't be the relationship being described. This one talks about the number of chores and the amount of allowance. Typically, students' chores that increase, they're going to get more money as a result. This is not a negative relationship. Brian's incorrect. If the variables move together, like in this example, the association should be considered positive. More chores, more money. They're going in the same direction. For number 12, we have scatterplot A, that the points are closer together, so that's why we call it a stronger association. The second one, which one appears to be linear, you'd have to go with scatterplot B because the points are lined up much more straighter. There's a slight curve to the scatterplot A, and that's why we wouldn't say that that one is linear. In your notebooks, these pages need to get folded, and I believe we are looking at page 91 and 92 where they need to be taped.